Hi friends, here we have to prove n cube plus 3n square plus 5n plus 3 is always divisible by 3. Let us prove this in three different ways because it is divisible by 3 and the question is about 3. So that's why let's prove it in three different ways. Okay, now n cube plus 3n square plus 5n plus 3. Let us just add 1n and subtract n. Why we are doing this? Because we want to make this 5n as 6n. Right. So there is already a 3 here, a 3 here. Let's try to make this 6n. So n cube plus 3n square plus 5n plus 3 plus n minus 1 is becoming n cube plus 3n square plus 6n plus 3 minus n. Right. Now this 3n square plus 6n plus 3, we can take 3 common. So we'll be left with n square plus 2n plus 1. Right. 3 common, n square plus 2n plus 1. This is becoming n plus 1 whole square. So n cube plus 3 times n plus 1 whole square minus n, which becomes n cube minus n plus 3 times n plus 1 whole square. This part is anyway divisible by 3. We have to we have to look into this. Earlier also we proved n cube minus n is always divisible by 3 because n cube minus n we can take n common, n times n squared minus 1, which is n times n minus 1 into n plus 1. We can write this one as n square minus 1 square is n minus 1 times n plus 1. So n minus 1, n plus 1. So any three consecutive numbers if we take, there will always be one multiple of 3. Right, whatever three numbers you take, 20, 21, 22, 49, 50, 51, any three numbers, because a multiple of 3 appears every third number. Right, if you see, every third number is a multiple of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Every third number is a multiple of 3. So if you take three continuous numbers, obviously there will always be one multiple of 3. So here this is a multiple of 3 and this is also a multiple of 3. So the total is definitely a multiple of 3. This is the first method. Second method is the induction method. Induction, proof by induction. What do we do in induction? We verify this for n equals 1 and prove that if it is true for some n, it will always be true for n plus 1. So for n, what is this becoming? 1 plus 3 plus 5 plus 3. This is becoming 12, which is obviously a multiple of 3. Now let's substitute let this sum is n plus 1. N plus 1 whole cube plus 3 times n plus 1 square. We are just substituting n plus 1 in the place of n plus 5 times n plus 1 plus 3. What is a plus b whole cube? A cube plus 3a square b plus 3ab square plus b cube. And n plus 1 cube becomes n cube plus 3a square b, 3n square plus 3ab square, which is 3n plus 1 times 3 times n square plus 2n plus 1 plus 5n plus 5 plus 3 is 5n plus 8. Now, let's look at this closely. N cube plus 3n square plus 3n, and let's take one 2n here. There is a 6n here, right? 3 to 6n. Let's take one 2n here and add to this 3n. Why we are doing this? Because we want to make this equal to this part, right? So 3n plus 1 of the 2n, which is 5n. So we'll be left with some 4n there. 3 times 2, 6n. Similarly, this one, let's take another 2 because we want to make it equal to 3. So this entire part is the expression where it is true for n. Right. So another 2 we take here. 3 times 1, 3. In 3 we'll take 2 here and 1 plus 2 becomes 3 and leave the remaining 1. So this second part becomes 3n square plus 4n plus 1 because 2n we have given here and 2 we have given here plus 5n plus 8. So this part is actually the first part is sum up to n. Now sum up to n is already divisible by 3. This is what induction is about, right? Now the remaining part. What is the remaining part? 3n square plus 4n plus 5n, which is 9n plus 1 plus 8, which is 9. So we can take 3 common, which is 3 times n square plus 3n plus 3. So this is clearly, this is also multiple of, this is also a multiple of 3 because there is 3, we have taken 3 common. So what does that mean? So n plus 1 cube is actually equal to sorry, the summation of n plus 1 is equal to summation of n plus 3 times some number. Obviously, because this is a multiple of 3, this is also a multiple of 3. So, summation of n plus 1 is a multiple of 3. Right. Induction proofs are generally lengthy. Right. They are not very entertaining like this. Right. It is more of algebraic expressions. They are not very entertaining. So, let's look at the third kind of this proof also earlier we discussed. Here we have n cube plus 3 n square plus 5n plus 3. Clearly, this and this are multiples of 3. We are worried about n cube and 5n. If n cube plus 5n is also a multiple of 3, then we are sorted. Right. We are we are worried about n cube plus 5n. Right. We are worried about n cube plus 5n only because the other two are anyway multiples of we can write n cube plus 5n as n times n square plus 5. Right? We are just taking n common. Now, any number you take n, any number is when divided by 3, n can either leave a remainder 0 or remainder 1 or remainder 2. Right? Any number, whatever number you take, it will either leave remainder 0 or 1 or 2 because every third number is a multiple of 3. There is no way it can leave a remainder greater than greater than 2, leave a remainder like 3 or 4 or 5. Right? Any number you take, always either leave remainders of 0, 1 or 2. So n can be 3n, in which case it will leave remainder of, or sorry, 3k, in which case it will leave remainder 0 or 3k plus 1 or 3k plus 2. Right. If it is already 3k, then there is nothing to prove. Right. If it is already 3k, then that means n cube plus 5 1, which is n into n square plus 5, n is already 3k, that means this is a multiple of. If it is 3k plus 1, then what happens to n square plus 5? 3k plus 1 whole square becomes 9k square plus 6k plus 1. So 3k plus 1 whole square plus 5, n square plus 5 becomes plus 5, 9k square plus 6x plus 6. Just we are adding plus 5 plus 6. So here 9 is multiple of 3, 6 also, 6 also. So that means n square plus 5 is a multiple of 3, is divisible by 3. So that means, so forget about n. N is not divisible by 3, but n square plus 5 is divisible by 3. Right. So that means 3k plus 1 is also sorted. What happens to 3k plus 2? Here also let's 3k plus 10 is not divisible by definitely 3. Right. What happens to n square plus 5? 3k plus 2 whole square plus 5. It becomes 9k square plus 12k plus 4 plus 5, which is 9. So 9 is a multiple of 3, 12 also multiple of 3, 9 also multiple of 3. So n square plus 5 is a multiple of 3, that means it is divisible by 3. So that means though n is not a multiple of 3, n square plus 5 is actually a multiple of 3, which means this n cube plus 5n is a multiple of 3 even when n is like 3x or n is like 3k or 3k plus 1 or 3k plus 2. Whatever is the number, this is always a multiple of 3. What does that mean? N cube plus 5 is always a multiple of 3. 3n square plus 3 is anyway a multiple of 3. So the total number is always divisible by 3. That these are the three proofs that we have given to prove this. Right guys? Thank you.